Hello and welcome to 7.4 Notes. Today's topic is on special right triangles, and there's two kinds of special right triangles, and the first kind is a 45-45-90 triangle. So the 45-45-90 triangle theorem states that in a 45-45-90 triangle, the hypotenuse is root 2 times as long as each leg. So if you have a 45-45-90 triangle, which this is, for one thing, it's isosceles, right? Because remember, if these two degrees are the same, then the sides opposite them are also the same. So it's also isosceles. And the relationship between the legs and the hypotenuse is that to go from the leg to the hypotenuse, you multiply by root 2. So as a quick little example, if this was, say, 10 inches long, of course that would be 10 inches long because in a 45-45-90 triangle, it's isosceles. And then this would be 10 times the square root of 2. And if the question says you can leave it in radical form, then hey, this is a math class. Just leave it in radical form. The answer would be 10 root 2. If you need it to multiply by a decimal, then of course root 2 is like 1.4142. So you would just multiply 10 by 1.4142, and that's the length of the hypotenuse. Okay, so what kinds of problems might you get based on this 45-45-90 theorem? Problems like this. Find the length of the hypotenuse. So in this case, the length of a leg is 20, so of course this one would be 20 as well, but that's not what it's asking. It's asking for the length of this hypotenuse. Okay, and the length of the hypotenuse is equal to the leg times root 2. So the answer is simply 20 root 2. And that's it. You're done. If you need to do that in decimal form, again, you can multiply 1.412 by 20 and get, 28.28. Okay? But that's not, really necessary. Only if it says to give me the answer in decimal form. Okay? And then the other kind of special right triangle is a 30-60-90 triangle. So in a 30-60-90 triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is root 3 times as long as the shorter leg. So that means this. If you have a 30-60-90 triangle, which this is, then the angle opposite the side opposite the smallest angle, which in this case is 30 degrees, is going to be your short side. And then the side opposite the 60 degrees is going to be your long side. And of course, in a right triangle, the hypotenuse is always really the longest side. It's across from the 90-degree angle. Okay, so the relationship is that to go from the shorter side to the hypotenuse, you multiply by 2. So if this was, say, 10 inches, then you multiply this by 2. This would be 20 inches. And to go from the short side to the long side, you multiply by root 3. So if this was 10 inches, then this would be 10 times root 3. Okay? And root 3 in decimal form is 1.7321. So you would just, if you wanted this answer to be in decimal form, you would multiply by 1.7321. 1.7321 times 10, in this case, would give you the length of the longer side. One thing I want to point out that is kind of important to notice is that if you need to find the length of the hypotenuse or if you need to find the length of the longer side, you always have to do it in relation to the shorter side, okay? Because if you notice, the length of the hypotenuse is 2 times the shorter leg, and the length of the longer leg is root 3 times the shorter leg. It's always in relation to the shorter leg. Okay? So say, for example, if I give you the longer leg and I ask you to find out what the length of the hypotenuse is, you first have to find out what the shorter leg is first, and then take that value and multiply by 2. Okay? So everything's always gotten through via the length of the shorter leg. Okay? And remember, just like all my other videos, if you ever need to pause this or rewind it or anything, of course, feel free to pause it and write things down that you might need to do. You're in total control of this presentation. Okay, so what kind of problems could you possibly get using this 30-60-90 triangle theorem? Well, problems like this. Find the value of x and y write your answer in simplest radical form. So we can keep our answer in radical form, but we have to find the values of x and y. This is a case, say if it said just to find the value of y, for example, and it didn't want x, we would still have to find the value of x anyway, because like I said just a moment ago, that to find the value of the hypotenuse or the longest leg, we always have to do it via the shorter leg, because both of our equations are regarding the shorter leg. Both of our equations involve the shorter leg. So let's work on that. Let's go from the longer leg to the shorter leg. Okay, so the answer is that the longer leg is equal to the shorter leg times root 3. So substituting in values, the longer leg is 20 and the shorter leg is x, and the relationship is shorter times root 3 is equal to the longer leg. So we have 20 is equal to x times root 3. In this case, x is my unknown value. The shorter leg is my unknown value. So I'm going to have to actually divide by root 3 over root 3 to get my answer, right, to get the x all by itself. And I get, after I divide out, or go root 3 divided by root 3 is 1, I get my answer. My answer is 20 over root 3. And I'm kind of done, right? I mean, that's kind of the answer, except that in math, we don't want radicals to be in the denominator, okay? So something that we've gone over, reviewed a little bit, and you really should have learned in Algebra 1, is how you get rid of a radical in the denominator. Well, you basically multiply by, excuse me, by your magic number 1. Okay, you multiply by your magic number 1. In this case, my magic number 1 is going to be root 3 over root 3, right? Root 3 over root 3 is 1, so I'm not changing the value of this number, I'm just changing how it kind of looks. And then 20 root 3 times root 3 over root 3 is going to be 20 root 3 in my numerator. But then in my denominator, root 3 times root 3 is just 3. So my answer is 20 root 3 over 3. So that's my answer. That's the value of x. That's my shorter side. And then to get the value of the longer side, we go hypotenuse equals 2 times the shorter leg. And substituting in values, we know that in this case we denoted the hypotenuse is y, and the shorter leg we just figured out is 20 root 3 over 3. So you simply just multiply that by 2. And the answer is 40 root 3 over 3. And we can keep our answer in simplest radical form, which this is, and there's no radical in the denominator, so we're good to go. That's the answer. The hypotenuse is 40 root 3 over 3. So, excuse me, that's the end of the presentation. If you have any questions or concerns, as usual, please feel free to contact me at your convenience, and it would be my pleasure to help you in any way I can. Thank you. Bye-bye.